Okay, ladies and gentlemen, this is your well-rounded math teacher, Mr. Percar. Excuse me. And we're going to be working with 8.1 solving exponential equations, that is. There's a graph over here for this function that says a type of bacteria starts with 3 and doubles every hour. So here's the equation for it. And we're going to talk about this equation. This is an exponential equation because our variable is an exponent. And this x, it says the graph of y equals 3 times x to the x, or 3 times 2 to the x power is shown here where x is in hours. This is usually time, your exponent. This 3 right here represents your initial amount. Because it starts off with 3 bacteria. And the 2 right there is our growth. It doubles every hour, okay? So if after 0 hours, you would get something like this, 3 times 2 to the 0 power. Anything to the 0 power, if you remember us talking about this, is equal to 1. I know that doesn't make sense for some of us, but it is 1. So that's equal to 3. So basically at time 0, it starts out at, if you look at your graph over here, at 3 units, okay? If you plugged in after an hour, this would be 3 times 2 to the first. Time would be 1 hour. Well, that's basically 2 to the first is 2, so this is 3 times 2, or that equals 6 right here. So it went from 3 to 6, it doubled. And after 2 hours, you can see it's going to double again. It's going to jump up to 12. So its growth is 2. It's doubling every hour. So 3, 6, 12. The next one would be 24, so on and so forth. So when will the number of bacteria reach 48? Well, you just got to kind of keep plugging it in. 3 times 2 to the second, well, we got 12 for that. 3 times 2 to the third would be 8 times 3. That would be 24. And finally, I'll do it in blue here. We get y equals 3 times 2 to the fourth. 2 to the fourth is 16 on your calculator. 16 times 3 is 48. So it would be after 4 hours. So you just got to keep plugging things in there until you kind of get an answer. So now it says, when will the number of bacteria reach 768? And how do you know? Well, we're just going to keep plugging in numbers until we figure it out. If you plug in 3 times 2 to the fifth, we'll use Desmos over here, and this is how you'd plug it in. 3 parentheses, then you'd plug in the 2, hit the little caret key, which is A to the B, and plug in 5, and we get 96. So it's not there yet. 3 times 2 to the sixth, I guess we'd plug that in. I think I can go back and plug in 6, and I get 192. Let's try 3 times 2 to the seventh. I'll go back again, type in 7, and I get 348. I think if I double this one more time, we're going to get what we're looking for. So if I do y equals 3 times 2 to the 8th, go back, hit 8, oops. AB to the 8th, and there it is, 768. So it would take 8 hours to get 768 bacteria in this culture, whatever they're working with. So that's just a little bit with exponential growth. Remember, 3 is the initial amount. Whatever this number is in front of the parentheses is your initial amount. And the number that's in the parentheses, that's your actual growth. We'll do this. The 2 in parentheses is my row. Sometimes it triples, sometimes it doubles, sometimes it's 4, it's quadrupling, whatever. Or you could have a decimal in there, like 1.5, 1.5 times every time period, whatever it is, okay? So that's one thing with exponentials. Now we're gonna kind of get into solving them. It says, undoing exponents, solve for b, okay? I wanna solve for b. Now, some people mess up with this a little bit. The first thing you gotta do is get b by itself. B is squared here. So I gotta get rid of that 50. So I'm gonna divide both sides by 50. And I get b squared equals, well, 200 divided by 50. I can plug it in over here if you're not sure. 200 divided by 50, it should be 4. And there it is. Well, what squared equals 4? Well, this is 2 squared. You could take the square to both sides, but I could just kind of keep finding numbers. What actually is 2, so b equals 2. And the opposite of squaring something is taking the square root of both sides, and I'm going to get 2 here. But sometimes you got to guess and check with numbers and just keep cubing them, taking them to the second, whatever it is, to figure out what your answer is. Let's look at this one. Okay. So first thing I'm going to do is get that b to the third by itself. So I'm going to divide both sides by 8. So b cubed equals 1,728, sorry, divided by, we got 8, 216. So what cubed is equal to 216? Boy, I don't know. I could try 4. 4 cubed equals 64, not even close. 5 cubed is going to end in a 5, so it's not going to be 5. Let's try 6. Cube that bad boy. There it is, 216. So this is kind of just a guess and check thing when you're dealing with these types of problems a little bit. So b equals 6. If you cube 6, you're going to get 216, and we're good to go. Let's move on to the next one. Now, these ones I know are going to be kind of confusing for us. Finding these exponents, basically you have to get the bases the same. When I'm looking at 2 to the x, this is my exponent. This is my base. Now, if I can get the bases to be the same on both sides of an equal sign, then the exponents have to be equal. Well, I already have 2 to the x power here. That's my base right there. I have to look at 8 and break that down and see if I can get it to actual base of 2. Well, kind of finding the prime factorization of this, I'd say this is 2 times 4. 2 is prime, and because it's divisible by 1 and 2, and that's it. 4 isn't prime. 4 is actually 2 times 2. So basically, the prime factorization 8 is 2 times 2 times 2, or 2 cubed. So that's what 8 is right there. Now, I have this equation, and both of the bases are the same. They're both 2. Well, if this equation is true and the bases are equal, then the equation, or the exponents have to be equal. So 3 has to equal x. And this only works when you get the bases to be the same. It could be 2, 4, 6, 8, 7, 15, whatever the base is, that's what you got to get them down to. And sometimes it's kind of hard to find those bases. You might have to work at it a little bit. So, well, 3 I can't break down anymore. Now, you got to remember, this is 3 to the x plus 1 power. You can kind of put that in parentheses there because that whole thing, 3 is raised to the x plus 1 power. So I'm assuming 243 breaks down to a power of 3. So I'm going to divide it by 3. 243 divided by 3 is 81. Good. 3 is prime. I know 81 is 9 times 9. 9 is 3 times 3. That's just good. And this 9 is 3 times 3. So I have all 3's here. I don't care about the 9's or the 81. That's not the prime factorization. But I'm multiplying 5 3's to get 243. So 243 is 3 to the 5th. Now look at these. These two bases are the same. If this equation is true, 3 to the 5th equals 3 to the x plus 1, then the exponents have to be equal if they have the same base. So 5 has to equal x plus 1. And then all we got to do is solve this equation. Subtracting 1, I get x equals 4. So that's how we solve for these variables in the exponent. Get the bases down to the same base and then set them equal. Set the exponents equal. Okay, so here's 4. Now this is an interesting one because you think, hey, let's break 128 down to a base of 4. So I'm going to take 128. It should be divisible by 4. If it's not, then we got to figure something else out. It is 32. 4 times 32. So I know 4 isn't prime, but we're going to try and work with 4. If I can get this down to a base of 4, I can set the exponents equal. 32 is 4 times 8. Good so far. 8 is 4 times 2. Well, wait a minute. This doesn't work because I have to have all 4s when I'm said and done. I can break this down to 2s, which that's what I'm going to have to do. But I'm also going to have to break 4 down to a base of 2. Now, this is where it gets a little bit interesting, okay? Because this 4 is 2 squared, but this whole 4 is raised to the x plus 1 power. So when we break that 4 down, we got to put it in parentheses because it's raised to the x plus 1 power. We'll get to that in a minute. We're going to clean that up in a second here. Let's go back to what we had here. Now I'm breaking this down to 2s. So the first thing I'm going to do is clean this up a little bit. I'm going to start over. And instead of going to 4s, I'm going to start off with that 4 times 32 again, but this 4 is going to be 2 times 2. This is going to be 4 times 8, but there we go again, 2 times 2. And 4 times 2, and this is 2 times 2. So what do we got here? 1, 2, 3, 4, 5, 6, 7. This 128 is 2 to the 7th. I don't have to put this in parentheses because this isn't raised to some power. Okay, so what do we do here? I can't just set the exponents equal because I have the parentheses here. Well, if I had x squared raised to the 3rd power, an exponent raised to another exponent, this exponent raised to another exponent, you multiply. This is x to the 6th. That's how I get rid of the parentheses. But you got to be careful because it's 2 times the x and 2 times the 1. So we have 2 to the 7th over here, and now we got 2 to the, well, 2 times x is 2x. And a lot of people would put plus 1 here, but you got to multiply that 2 times the 1 also. So plus 2. Now I have the same base. No more parentheses. And I can say that these exponents must be equal if this is true. So 7 equals 2x plus 2. So I'm going to subtract 2 from both sides, and 2x equals 5. Divide by 2, and x equals 2.5. And there we go. We solved another exponential equation for that variable. You would think, hey, maybe I can get a base of 9. Well, let's look at 27. That's 9 times 3. So right there I have a 9, but I have a 3 on this side, so that's not going to work. But I can break them both down to a base of 3. I'll do 9 on this side. Well, 9 is just 3 times 3. That's it. So this 9 right here is 3 squared, but that's raised to this power, so I have to put it in parentheses, 2x minus 1. So we got to multiply those exponents in a minute. 27 to the x, so I'm going to have to put whatever 27 is, 3 to some power raised to the x power, this x right here. 27 is 3 times 9. 9 is 3 times 3. So 27 is actually 3 to the 3rd power. Okay, so getting rid of the parentheses now. Power to power, we multiply that 2 through there. So that's 3 going to be 2 times 2 is 4x. And then 2 times negative 1 is negative 2 equals 3 to the, this is simple, just 3 times x is 3x. Okay, my bases are equal now. We figured it out. So I can say 4x minus 2 equals 3x. Some people add 2 to both sides and then subtract 3x. I'm just going to do this. I'm just going to subtract 4x from both sides. And I get negative 2. Whoops. Almost put negative 2x there. Equals negative x. Well, I don't want negative x, so I divide both sides by negative 1. And I end up with x equals 2. So there's some work with exponential equations. Your assignment is the same thing. 16 can be a base of 4, so I'm going to help you with that first one. That's 4 times 4. So let's look at that. That's 4 to the 2x equals, well, 16 is 4 squared, but that's equal to the 2x minus 5 power. So you got to do some parenthesis work there. You got to distribute that 2 through there and get 4 to the 2x equals 4 to the, well, 2 times 2 is 4x, and 2 times that negative 5 is negative 10. So there we go. There the 4's are equal. So you take your exponents, 2x, and set that equal to 4x minus 10, and solve that equation, and that would be your answer, okay? That's kind of what you're doing with this whole thing here. This is probably going to be a base of 2. This one I think you could do 25, or I'd probably do base of 5 to keep it easy. For this one right here, 6, you have the 4 there, raised to the x plus 2 power, but you got to get rid of the 3 before you can do anything there. When I cancel out that 3, I get 4 to the x plus 2 equals, oh boy, what do we got there? 192 divided by 3, 64. So I'm going to tell you this. You can do a base of 4 for this one. For this problem. 64 is, I think it's 4 to the, you'll figure it out. Just keep dividing by 4. You can skip 8. For this one, okay, if I had x to the 5th times x to the 3rd, this equals, you add exponents when you're multiplying when you have the same base. This is x to the 8th. So for this problem, 2 to the x times 2 to the 3x minus 2, you got to get 1 2 on that side. You can't have 2 2's there. So this is 2 to the, add the exponents. X plus 3x is 4x minus 2 equals 2 to the negative 6, and then you can set the bases equal. You can go ahead and try this bad boy and see how you do. Set up your little equation and try it, and that's it for this worksheet. Finish up, and we'll see you guys later.